In order to start building our model for bond energy, we need to know how many nearest neighbors a particle in a large amount of a substance would have. In other words, if we have a substance where the particles are packed as tightly as possible, and then we pick a single particle, how many particles will be the equilibrium distance away from that particle? To do that, we're going to set up a system of tightly packed particles. We're going to use this particle here in the center as our test particle, and then count how many nearest neighbors it has. Set up like this, there's no places we could put another particle such that this central particle would be the equilibrium distance away from it. So let's just count how many particles are the equilibrium distance away from that center particle. Let's start with this outer ring. It has 1, 2, 3, 4, 5, 6 particles. Then we'll count the particles that are on top, 7, 8, 9. And then the particles on the bottom, 10, 11, 12. This is a pretty good approximation. We can imagine extending this pattern out until we have a huge number of particles. On average, a particle in such a substance will have about 12 nearest neighbors. This information is going to allow us to start figuring out how much bond energy we should have for a substance.